Welcome, I'm Bill Wake. We're here working on a calculator that can handle inches, feet, and yards. And we're to the point we want to do a little bit of an editor, providing a backspace. We have a key allocated to it, but we don't actually do it yet. All right, now I think some of the stuff we did last week is setting that up pretty well. We took away, the old way was like a regular calculator. As you enter it, the operations get applied and stuff like that. And so you always kind of have a partial result there. We're instead writing out the whole expression that gets typed as it gets typed and kind of syntax checking it along the way, but running, evaluating it at the end. I think that should be okay. All right, so I didn't run my unit test yet. Let me do that. Sorry, I'm a couple minutes late. We had some family stop by for lunch, so. Okay, you're running. Let's see what we can find. Well, we have InputBuffer. Okay. Yeah, we have the string you're accumulating. As you type bits, we have the string you're accumulating. Each one comes in, so a digit comes in as a string, an operator comes in as a string, and so on. Those all end up in the input buffer, and we have remove last if. Well, I think we can. Yeah, we really. It's really just kind of remove last, if true. All right, so I think that's all it's going to take. Let's close some of this stuff. Okay, we can do a test up at the content view level. Did they finish? Slow. It doesn't pay to close your environment. Now, WWDC's this week. I was trying to find out what sessions they're offering, and I haven't seen anything yet. I know the keynote was today. I guess they'll tell us day by day. Wow. Oh, that little motion. All right. Once it gets started, it's not too bad, but see if we can put this on our screen. Oh, I can turn that on. Are they in fact running? Okay. Okay, here we go. Okay. It used to be a thing to say, oh, you should have a 10-minute build. I'm apparently not equipped with the patience for it. Maybe no longer equipped is maybe accurate. All right. Well, that was easy. All right, let's run it. Okay, so what I'm expecting to do, if I did 7 feet, 5 inches. Oh, wait, that should have been 7 feet 3 inches. I'd backspace, get rid of IN, backspace, get rid of 5, and go on from there. Now, the way we do the calculator, the checking, so we don't let you put 2 operators in a row. We remove one, and same thing on the units. We let the last one win. So everything is being done at the current string. And so if we delete something, I don't anticipate a problem. So let's do our content view. We'll put some tests in, but I think I'm hopeful this is easy. Okay. We already gave an operator for it, less than. So we've got this backspace key and a less than that maps to it from our little language here. Let's do 5 feet 2 inches. Maybe make it 2 inches in. If you did a delete, we get rid of the inches and the 2, and if I did 12 equals, then I expect it to be 6 feet, which is 2 yards. Okay, so this is 2 deletes, taking out these last 2 things. And I'll run this. And he certainly should fail. Okay, and I guess what am I expecting? I am expecting 5 feet 2 in, 12 in. Actually, it's still not right. Okay, let's do that. I'm expecting 5 feet 2 inches, 12 inches, so it'll be 2 yards 2 inches, I expect. 2 yards 2 inches. Okay, because it implicitly adds, if you put inches twice, it'll add them both. Okay. Let's go to the keypad. Okay, so keypad is what maps a keystroke to a calculator button. All right, now, if I could remember I guess that's this is the delete key. All right, so we're going to say calculator.clear? No, backspace with calculator. A little bit of a weird thing, but these, it's sort of a way to get the function of calculator.backspace passed in without too much grief. It's a little redundant looking to me, but that's okay. All right, this doesn't exist. Calculator does. Okay, so backspace. We don't need the name of the key because we're not doing anything with it. Digit does, but unit does. All right. Well, this is, I believe all we need is input.remove last if, and then the function takes a string and it is always true. Okay, so we're always deleting it if we can. All right, and then if, where's InputBuffer? Okay, notice that it already checks for is empty. So if it only does this if it's not empty. So if it is empty, nothing happens. All right, we'll put a test in for that just to verify, but I think that's all there is to this. Okay, we've already tested this. Let's make sure. Again, I'll just do it at this high-level test. I think this thing is just so flat. I in the sense of the connection between the display and the buttons and what the model is. The only complexity is the arithmetic expressions are complex, but they're not problematic, I guess. They're not that complicated. We have a couple stacks to evaluate them, but in general, I can drive most of the behaviors I want to see. I can drive from the keypad. All right, so a couple of deletes that should be harmless. 12 inches equals should be 1 foot. And notice our earlier test case covered deleting a 2-character input or a 1-character input. So I think we've covered everything I expect to be an issue. All right, so 7 feet, 8 inches, 99 inches, backspace, yeah, 9 inches, 8 feet, 5 inches, so that's 2 yards, 2 feet, 5 inches. Okay. Yeah, nice. Not everything has to be hard, right? Okay, implement backspace. Now you could imagine a more complicated backspace, or that I could edit this by clicking and typing in new things in the middle and stuff like that. We're not really supporting that. I don't intend to, and I'm not going to. Okay, put it that way. Okay. Did I commit? Yes. Backspace. Okay. Now, underflow, negative numbers. If you start with an operator, you should load the previous operator. Yeah, that's a good thing. Separate error field to move keypad constants. That's a refactoring, reflecting that the keypad is a relatively high-level place to put stuff. These, I don't know, it's a, like we have people referencing these because they need to know in the expression, like, what do I expect? Now, we talked a little, there's a case to make that as we type these in, we ought to be converting them to an internal type, and then that type would just have, add, subtract, multiply, divide as like an enum type, one for each possible thing in coming from the keypad. So these keypad operations, backspace, digit, unit, op, enter, they're all, they all could become their own thing instead of being strings in the input buffer. Because if there's strings in the input buffer, we have to tie our handling in our calculator to what they are. So I don't know. It would be nice to do that. Like keypad could do that. I go back and forth on keypad. These functions are awkward. We tried a different way to do them at some point, and I think we were maybe just too far away to kind of make it stick. But like somehow I want to. Well, I could. I could do this, like I could write this as nothing in calculator.clear, because we know the calculator. Okay. That would be another way to write that. I don't know that it's any worse. And we probably could. Yeah. Okay. Yeah. That would let the, instead of clear, I could say calculator.handle and then some object that's an enum that's, got different units and different things and stuff like that. Maybe get the strings out of there. It would be nice, because we are seeing some crossover a little bit. Well, operator knows this too. Yeah, there's just a lot of that going on. I mean, string is kind of the wrong type. All right. Well, what do I want to do next, though, is a real question. Okay, negative numbers. Well, this one's probably more important. Yeah, let's deal with that. Okay, so what happens if you type 0 inches minus 5 inches? I think you just get 5. Minus 1 yard. Okay, that's interesting. I mean, we really have this plus or minus button on the operator side. Well, okay, I gotta do this in a way I can understand it. 0 minus 5 inches. Oh, that's not gonna be allowed. Okay, 0 inches minus 5 inches equals. What does that mean? Well, if you added 5 inches to it, you'd get 1 yard, 2 feet. I don't know. You'd get. I think what it's saying is negative 1 yard plus 2 feet plus 7 inches. Interesting. I don't know the right way to write this. That's the thing. So options. I could say minus 5 inches. Let's take minus. How about 0 inches minus 17 inches equals? I could say that's minus 1 foot minus 5 inches. I think that would be justified. I could, or I could like parenthesize it, 1 foot 5 inches. That kind of puts it on you. I think this is better. But it encourages you to type something that you can't type. Both of them do. Now, if you're entering it, let's talk about plus or minus. In a typical calculator, you'd hit 5 plus or minus, and it shows you -5 right away. But as a written expression, that's not the way we normally write it in math, is it? Oh, am I going to have to differentiate negative signs? I hate that idea. Because 7 minus 1 is 6. 7 minus -1 is now allowed. Maybe plus or minus should show. I mean, if you were an accountant, right, you'd put parentheses around them and put like parenthesis 1 paren. I don't like the asymmetry that I'm going to display it in a way that you can't type it. Now, maybe I can make that work. I mean, if you type minus minus, you are on your way to negating something. Oh, excuse me. But right now, if you type an operator, we remove the last operator. And I don't know, we're not quite there, are we? Because if it, we check if it starts with an error operator somewhere. Where's evaluate? Or is it expression? I think expression does. No? Well, that's one of the things we need to do. Okay, what would it take? All right, what if somebody types -1 foot 5 inches? Do you think that's -1 foot plus 5 inches? Or do you think it's -1 foot minus 5 inches? Excuse me. Well, I thought this would be easier, not easy. I don't want to refactor all day. I mean, Backspace was so easy. It should buy us some time to do some other work. If this is interpreted as a negative and a positive, right? But then this conflicts with this. If you start with an operator, you should load the previous result. So if I type 7 equals -5 equals, I should get 2. But if I take the other interpretation, 7 equals, get 7, -5 equals, I might get -5. Now we could put something else in to represent that. Like say at represents the previous result and force you to pull it in. Or last, we have a last key. Or we could do like, Git has notation for oh, is it arrow -1 or something like that, right? Or dot -1 to reference previous results. That's okay. I I think we can make negation work. But I do think it would work better if our calculator worked from some other type instead of string all the time. Okay. Sorry, who calls this? Message unit. Okay, that can be private. Okay. Yeah, so instead of so what I'm proposing is the keypad generates instances of some type, and then we just kind of have a handle type here. And usually handle is, well, in some cases it's shove it onto the input. In some cases it's do some stuff. I guess I can do that. All right, so we'll need keypad, and this is kind of a refactoring. We're refactoring to isolate the front side, the interaction side being the keypad, from the back side being the calculator logic. So these are all calls. All right, let's make a new type. We'll make it in here and then we'll pull it out. It's an enum. And this is, well, it's not keystrokes, but I don't have a better word right now. Public enum keystroke. And then there are cases. Well, let's take them one at a time. So here's clear as a case. Case clear. There's no parameters, so it doesn't need anything more than that. And I'm going to do them one at a time. So I could do case. Well, I may convert these to their own thing too. These would pass in the digit for themselves. And equals would be its own event as well. Okay. But I want to make a method in calculator. I'm going to call it handle. And keystroke. We got to work on that name. The point is, they're not keystrokes anymore. They're abstract operations. They're entries. All right. So if you call handle, we're going to switch on the type of keystroke, and case clear. We're going to do something. Well, what are we going to do? We're going to call clear with No argument. Okay. So I think, well, clear, nothing. Okay. Clear, well, let's even take that out. We don't need it. Clear, we'll make this optional for now, but I think we're going to quickly get to the point of not needing it. Okay, case clear, cannot match values. I think the compiler could guess that for me. At least tell me, like, you forgot your dot. All right, so right now, nothing has changed. Is that true? Calculator, sorry, keypad. Oh, it's still calling calculator clear. Okay, this should change nothing. No one's using it. All right, but the keystrokes, oops, the key takes string to void. All right. So let's, how can I do this? I want to be incremental. So calculator clear, I'd like to call calculator.handle, but that's not possible here. So I have to have a function that takes a string in, and then I'm just going to say calculator.handle.clear. Okay, so you give me a string, extra arguments and positions. Oh. You give me a string, which will be C. I promptly ignore it, and I say, calculator is just going to do whatever it does for clear. All right, I think this should work. All right, and I'm going to go with entry. And then same thing down here. Okay. All right, so handle clear as an entry. And enum with cases for each type of keystroke, I think. Okay, so clear. Now, I don't think anybody calls clear. Fine, select a text, maybe a test. Okay. Now this is a test of the calculator, so it's reasonable for us to say handle dot clear. Okay, so where's the other one? Okay, and we're checking that it does its job if you do. We're pushing people away from calling clear, and now function clear is private, and we don't need an argument. All right, so down here, okay, it didn't have one anyway. All right. Okay, and then this name, I think, is enter. We didn't use enter before? Oh, we did. It knows the difference because they're different types. Yeah, we'll fix that as we go. They have two different types. So they are two different functions. I think we'll be okay. All right. Make clear private. Good. Okay, next. Well, good old Backspace. Calculator.enter Backspace. Okay. This should fail. Well, yeah. All right. We just call it Backspace. Make this, ignore it. All right. Okay, now units. Ops, interesting. We have our operator. It knows precedence, name, and how to evaluate. That seems like a good thing. Okay, I don't know. We may be able to fold those together. Let's keep that around a minute. All right. Digits and enter. Well, let's call enter equals, and let's add that one in. Case equals. Go to calculator. Call enter with nothing. I think we'll call this equals. Okay. Backspace. I guess I didn't finish that, right? I didn't make it private. Okay, this should work. We'll catch both these. All right, now Backspace, I'm going to make that private and remove this. We should get some warnings from the tests. Well, maybe not. Maybe one place in content view test, if that. No, okay, even better. Equals, make that private. That one I think is probably used more in our stuff, in our tests. Yeah. All right. This is going to be calculation.enter dot equals. So, I mean, we are moving away from the text of these keystrokes, which is, well, it's what we need. All right, that should all be good. Okay. Yeah, notice how I'm pushing off the ones. Okay. Now this, I think the time has come to make some units. I don't think we have anything like that yet. Imperial units. Well, we kind of do. Imperial units. This would be a good place to put them. Okay, so let's make them case inch. Oh, is that gonna be trouble? Case foot, case yard. Yeah. I mean, I think you can do this like Kotlin can. I don't think it would hurt us to spell it out. The actual word for it. Okay. Now, there's no harm in adding that. Okay. Keypad. So I think we need a unit up here. Unit with an imperial unit. Singular might be better there. Okay. And then these become that. Enter unit yard. Okay. Print. Yard, foot, inch. Okay. And then calculator has to take them into account. Case unit of let unit. Well, we're going to call unit of some value. I don't know if it'll let me keep these names around. Unit dot. Well, I think that should be a custom string convertible. Let's call it description. I we should be pushing this down, but for now we'll do this. Okay. Extension imperial units extends custom string convertible. Public var description of string, and then this will be switch self case dot inch. Well, return inch case dot foot, return ft case dot yard, return yd. Okay, that should be exhaustive. Okay, back here, cannot call value of non-function type. Imperial units. I'm going to call this enter unit. I think I had too many names floating around the same. Yeah. Okay. Can't call everything unit. Okay, now have I covered my keypad case? Where's my units? There we go. Yes. Okay. Oops. Closure expression should have a single space. Okay. It looks all right to me. Before and after a comma. Okay. Okay, good. Now the tests. Anybody called unit, or we're now called inner unit. Let's find who these are. Okay, so now they should become enter unit with dot inch. Okay. Oh, spell it out. Inch. Make sure that one's okay. All right. So enter inch. A lot of inches. Okay. Now this value string, he's coming because I do this. What if I pass unit and let him do it? Enter unit. So he takes a unit. What do we call that a minute ago? Value. Okay. Take description off here. Push it in here. Enter unit. Unit of imperial. And then value dot description. All right. Okay, so this, well, we got those digits. I guess what's left. Enter. There's operators. Yeah, I think I can do this with the operators. Let's make an op. And no, I don't want op. Gosh, I really want add, subtract, multiply, and divide. So I'm going to differentiate them even more, and then I can take care of them separately a little more. Okay, divided is the first row. This one. So this is calculator, enter, dot divide. Oops. Right. And then over here, he's got to be handling them. And subtract, multiply, divide. Okay. They're going to, well, for now, they can just do their thing. Op of plus. Oops. Op of minus. Op of keypad dot multiply. That's a nice X cross kind of thing. And keypad dot divide. Right. Okay, subtract. Okay. Keypad. That's weird. These two match that. That. Close key. Close that. That seems right. What am I leaving out? Oh, one too many. Okay. Divide works. Let's do multiply. Subtract and add. Okay. So now op is gone from here, and let's make it private. And we should get some test complaints, I imagine. I mean, I'm pretty sure we saw them. Okay, so any op, we're going to change it to the corresponding operator. And I don't think one's French and one's Latin or anything like that. I don't know how we got both those. Okay. All right, on our keypad, I think we just have digits left. 3, 6, 9, 10 digits. Everybody else is calling enter. Okay. Let's take our break. So we'll be back in 3 or 4 minutes. We'll get these digits done, and then we can simplify this stuff, I think, substantially. All right, see you in a few minutes. Welcome back. All right, let's get these digits done. We add them here. I think we want to work with int, although we treat them as strings, but I think their true nature is that they're an integer of some sort. Let's see, so we need to handle digit in our calculator. Digit let value, and I think we just call it digit. And we'll just pass it in like that for now. Okay, and keypad should use it. Digit 7. Eight, 9, 4, 5, 6, 1, 2, and 0. Okay, here we should work. We'll make that thing private, figure out what tests are still using digit. Function digit. Here we go. Build, see what breaks. Nothing? That seems odd. Yeah, that's not correct. Well, I never know if it's building the tests. I guess it doesn't by default. All right. So this is calc.enter digit of 4. Two. Suppose I could have globally replaced them. Since he has 3 and 6 a lot more. Okay, there's 9. Should have caught that while I was pasting. All right. Oh. A little misplaced there. Okay, so notice what this has done now since we got them all. Everything is all calc.enter. No separate functions. All right, so make digits, use calculator.enter. Then in calculator, now I think this should really take Well, I'm going to be very tempted to endline all these, honestly. They're all 2-liners. This one's not. Okay. What's funny is I think I really need, I mean, everybody should be ending up on the input, right? For the most part, except Backspace, obviously. And so I think I should just be passing. I think I should be passing the entry in, but making it decoded is a little unfortunate. Yeah, so I mean, what my next step is to make the input buffer work with entries instead of strings. Okay, which means each of these things is going to push itself down. Like, I think these should just... Is operator, what's used for? Okay. That function would be nice on our entries. Yeah. Okay, I want them to deal with that. This is a challenging place because sometimes you just, like, I just want to get to the value. I know it's a unit at this point, and I'd like to just get that. Let's make them take the entry. Okay, so enter unit. I want to take the entry. So I'll make a new one. Private func enter unit entry. Okay. Now, if I can get let unit equal entry dot as unit. Okay, that does not exist yet. And then I can call enter unit. Oh, excuse me, sorry. I can call that and then call enter unit with the unit. Okay, so this doesn't exist yet. Let's go to entry and we'll give it some helpers. So this is a public function, is as unit. Or yeah, returns an imperial unit. Okay. And then do I want to put an unknown in here? Or a none? None might be more accurate. Okay, so in here, if the unit is not valid, I mean, if it's a unit type, okay, let's cover that case first. Keypad still has it. If let dot unit of value equals self, then oh yeah, case. If case let, if that thing is a unit with a value, then return value. And otherwise, I'm going to say none and add that in here. Now that's going to change things. None. Okay. I'm not going to do any adjustment. Well, where's that string coming from? That's down here. Let's say it's empty, then it's inches per inch. Well, it's really just 1.0. Okay. That's a none, and then case none, return empty string. Okay. Now here, okay, he does now. I'm gonna, somebody was calling as unit, that's in here, as unit. Okay, that, where's enter unit now? Enter unit should be entry. Discourage none. I don't want an optional value. Unspecified. Okay, calculator.swift. Enter unit entry. All right. So now who calls this one should be one place. We'll inline that. Must is unit. This goes away. Keypad. Okay, so we pass the whole entry to enter unit. Okay, now there's still something weird here. Is unit. Is unit value suffix? Well, that's we're going to get away from that one. All right, I guess we're pushing down first. All right, now these, I think they should just pass themselves. If op took this, that would be progress. Okay, so where's op? Okay, so we want entry. Entry. And then if well, I want to convert that to the string. Okay, let's it's this temptation to take a big leap, and maybe I'd be better off, but if he's not an operator, then I'm thinking we should just do nothing. All right, so we got an entry. Switch entry case add well, that also seems like a question. I guess if I could ask for the operator for, that would be a good thing, right? So if I said op of entry dot operator, that name is not available because it's a reserved word or a semi-reserved word. I can never tell. Entry dot maybe op. Entry dot op, and yeah, that would push it into entry. Okay, so let's give entry an op. Op returns an operator. It returns, I think that should return an operator, and then switch self of case add return operator dot make I guess plus and minus. Again, I think we can simplify all this if we just get it switched over first. Okay, now default okay, we can return that. Okay. Gives us the op. Dot name. well, let's let name equal that. And then this input to remove last if is operator. I guess it's going to take a name. Okay. Input.add. Name. All right, so this becomes op of entry. And then I think we can just say subtract, multiply, divide. And this one should go away. I was surprised it didn't complain about that earlier. Okay. I shall conform. Fine. Okay. I think we're closing in. All right, so these just deal with the entry. Right, so let's do digit. Private func digit entry of entry input dot add this, I'm just inlining right away, is going to be entry dot as digit. Okay. And then he has none. Okay. I think we'll take the, do we want the string or the int? Let's make that the string. Okay. So this is kind of the same. If case let digit of value, then we're going to return value as a string. Otherwise, I'm going to return, I mean, this is sort of a can't happen thing. I'm going to return something that's just kind of like weirdly wrong. Yeah, I mean, that's the price we're paying for letting this type tell us, you know, things that only apply to a subset of them. And I don't have to put throws everywhere. It will show up funny if we don't use the right thing. So I'm not too nervous there. As digit, yeah, it's good there. Okay. This one. Oh, right. Excuse me. Okay. Well, that's pretty minimalist. I'm okay there. All right. So make everybody pass entry around rather than string. Okay. And then, all right, let's go back to keypad. Let's clean up in there. So this should become its own thing. New file, entry. All right, now the other one is, before we leave this, well, I still have these things floating around. They notice they all have a different form now. So everybody's taking a string that they promptly throw away, and then they're calling calculator.enter on that stuff. All right, I think we can find whoever calls this function, the function on key, and just pass them the thing. Okay, just pass them the entry. And that's more separation we're getting. So this thing doesn't have to, I don't even think it needs the calculator anymore. Yeah, that's gone. So, yeah, I think whoever calls this needs the calculator. So, who calls that function? Well, it just might be in content view. He's got the keypad. Here's the button with keyed up press. Okay, I think we took this out by agreement. He calls keyed up press. Okay, let's see what that does. It does the action of name. Well, he doesn't need to know. I mean, I think we could just call calculator dot enter whatever this value is. Okay. So I'm going to, I guess I'm going to make that a leap. Okay, so this is entry of entry. All right. Self dot entry equals entry. Got the entry there. Action goes away. I want this to return the entry. Well, gee, I don't even know if I get anything from that. Nobody gets to change this. Let's change this to private set. And let's make this private set. I guess I still have to say let. That's dealt with here. I think it's just entry. Okay, so cannot be applied to read-only property. Maybe this is just let then. Okay, so that's, well, we're letting you look at them. That's public. Okay. So content view now, it doesn't have key.press. It just is going to say, do something with key.name. Well, what it's going to do is calculator.enter key.entry. Okay. And actually, well, yeah, those are going to have some grief. Okay, but this simplifies to that. I think we're going to have to add a TBD. We can add it on key. Calculator. Well, this feels like a major improvement. Crossed my mind to do something like this way early on. I really wish I had now. It wouldn't have taken an hour and a half or an hour, whatever we're at. I guess the first half hour was Backspace, so an hour. Grr. Okay, let's see if I missed anything. Okay. I guess this is really key knows its name. which I don't even want to test. Yeah, I don't even want to test that. Let's take this test out. Key tests. I just don't think it adds anything to say, here's a value, you stick something in the name, it's the name, you stick it in the action or the entry, and it's the entry. Like, boring. All right, keypad. This is much, much nicer. Definitely deserve to do that early on. Notice there's no strings coming in. Everything is, well, we got digits or units. Okay, let's make sure this all works. Now, in effect, we're dispatching through a sort of, I don't know, spreader function that divides things up. But I don't think we need our calculator now. Nothing uses it. Okay, so let's take that off. Well, we don't really need any of this stuff, do we? Let's just make this equals that. Should answer with 2 brackets. This is not needed. Okay. Before we had to pass calculator and you couldn't define these up there because you needed calculator to do it. That's all good. All right. A build should show at least one place that cares. Yep. Keypad does not need calculator anymore. Now content view does. Input calculator. Well, this could just be equals. Now it's just kind of a constant. Good. All right. 77 feet, 15 inches is a bunch of yards. 3 inches. Okay. Yeah. I think we're, let's see. Remove calculator from keypad. Well, that was definitely a barrier to us before. Having to pass that in meant some gyrations in how we initialize this stuff. I don't even know if you need this anymore. I think it defaults to that. We needed it before because it was more complicated than just setting a field. But now it's not. Okay. Remove unneeded init from content view. Okay, gosh. All this is great. Where are we here? Negative numbers. Okay, a lot of this was to make it possible to do negatives as input. Now I think I'm okay treating that as -1 foot plus 5 inches, and that's 7 inches, -7 inches. I think. Maybe that takes away the plus or minus operator. I think I want that to display like that. That's a display issue, but it brings up an input issue as well. Okay. Calculator. All right. So if I guess I want to make input work on entries now. These all take entries. That's good. Equals doesn't, but I don't think it has to at this point. Clear backspace should not. Okay. So input buffer, I would like to work on. Okay, and it's going to be trickier. All right, so entry, I need that to be custom string convertible. And then this is really, each of these cases is its own thing. Well, we're working on it. Okay. I noticed Swift, Paul Hudson put out a little blurb on some stuff going in the language side. And he mentioned that cases like this, where every one of them starts with return, they're going to let you not put the return anymore. That'll be something. Okay, TBD is that clear. In terms of the string description of it, it doesn't show up in there. So I'm just going to make it empty. Backspace doesn't show up. We'll put it up there too. Equals. Well, right now it doesn't show up. I kind of think it should eventually. But we'll. Okay. Well, this one we've put in spaces. All right, now this one. All right, now where should these? Um, multiply. Okay, now that shouldn't affect anything. All right, so input is empty, that's fine. Input to string, input buffer to string. Okay, that's what's going to change. All right, so if these things are entries, well, elements is going to have to be an entry. Make iterator goes over entry. Is empty is fine. Last is entry. Whatever uses that. Entry. String. This one's going to be interesting. Let's keep it like this for a moment. To string. Okay. Elements dot map description. Map each element to its description and join them. And so that's what counts, that entry, these things are empty strings. They don't really show up anyway. Everybody who shows up is a positive string. Okay. I think entry calculator. All right, an input buffer. I think we've got everybody in there. Now the callers are going to be all messed up. Okay, so entry as digit. Well, we just want entry. And no as digit there. Okay. And we're going to add entry here. Let's add the entry. Input.last.description. That we will fix. Okay, append. Pending.append. This thing works on input. Okay. Commands. Oh dear. Command dot description will keep us. What's the type of command? Right, thanks. Well, it's going to be entry pending is let's make pending an input buffer. Is that what he is? So we accumulate these into pending. And parse them. I guess it is a string. So let's do command.description here. Yeah, this is still strings. Okay. All right, so we never needed this or this. All right. What did I say what we did? I guess basically we make InputBuffer work with entry instead of string. Right. Okay, I'm going to have to... I feel like I want to just stop and read everything from the top. Okay, let's start with calculator. Okay, so we have an input. If it's not empty, we're going to show it. Otherwise, we show the result. Both those seem okay. Let me tackle this one. I just want to get this rename imperial unit. Okay. Okay. Calculator. So calculator's job is really, I manage and accumulate an input buffer, and then when you hit enter or equals, I produce a result. Okay. That seems good. Well, it seems like a good goal. Now this result bit, the interesting thing to me there is I almost want to just say put the result in the input string. And that's the display, not so much the choice between them. But that's another project for another day. Okay, now is operator and is unit. This is not the easy way. Okay. It's certainly a question that entry can answer. So let's make entry answer that question. Is unit. Okay. Operator. I guess we can put it up here. Public func is operator returns a Boolean. Okay. And it's basically this. If you're add or subtract or multiply or divide, at least as of today, then we return true. Otherwise return false. Okay. I mean, that should be simpler, right? Return, well, let's say return, just self. How about this? Dot contains dot I don't know if I could make this a set explicitly. Contains the satisfies. Wait, is set dot. Sorry, I thought there was just a simple check. Yeah, contains one entry. Okay. Contains self, return true, else return false. And entry conformed hashable. Okay, I'm going to go back. Okay, that's the... Okay, and then is... What's the other one? Is unit. Well, we want to say case, if case let dot unit of something equals self, return true, otherwise return false. And I guess I don't need to say let. Yeah. If case unit is, if the self is a unit of some sort, return true, otherwise return false. All right, those seem very straightforward. Okay. And then this. So I think the remove last if should take an entry. Entry goes to Boolean. And if the condition holds, we don't want to look at the description anymore, remove it. Okay, and then calculator should be, I should have complaints, there they are, is unit, okay. It's not that function so much as $0 dot is unit. And this is similarly $0 dot is operator. Okay, so now we're working on units, and these little helpers go away. Is operator. I guess that's really input dot last dot is operator. Input dot last is operator, then oops. Okay. I think that should be good. Okay. And I like this in terms of the editing and deleting. I mean, it makes sense to say an entry is an entity by itself, and we don't have to know, like, oh, if you were a unit, you ended with a space and you had 4 characters and all that stuff. That's no longer relevant. Okay. I think it's improving. All right. I don't think there's anything interesting in here at this point. We switch this to entry. That's all. Okay. So I'm going to close that one. Keypad. Well, I'd still like to get these out, but we're done. All right. Calculator. Okay. I think calculator's good. Entry. All right. Imperial unit. Okay. Now this, somehow we ought to be able to fold this away, or at least maybe it moves over to the entry. But this stuff is okay. Yeah, we'll let it go. Period. Expression. All right, now this one is reading input buffer. It's still well, I sure feel like it ought to be reading entries. Right. I mean, it's reading an input buffer, so it's definitely getting entries. So let's make that reflect that. Entry. Okay. Now entry.description. Again, I think now we can go to entries. Case dot digit dot unit. Then append entry.description. Okay, I think that's okay. And this is case add, subtract, multiply, divide. We're going to do parse pending entry. Entry.description. Yeah, that's a little weird. Okay. I'm going to leave it for a future day. I don't know what we'll do for the next 10 minutes, but we've pulled out the operator. We're making the description so that we can turn it back into an operator so we can get the precedence. That definitely can be part of entry. Let's I'm going to add something that's like, yeah, decide whether operator is separate from entry. Because I could certainly ask for a precedence on those things and get it. Okay. All right. So I think we will do. Let's work on displaying negative numbers. So just the display side, but I think we also need to worry about inputting negative numbers. or plus or minus. Okay, I think this one may go away. All right. Well, I'm going to say that I think we can separate the sign. If something is negative inches, we're going to calculate its length in positive and then put a negative in front of each digit that we show. Each non-zero digit. Yeah. Okay. That is, well, we were in expression. It's got to be part of value. Well, got to, okay, here's format. Imperial formatter function. All right, this is the thing that does dividing. All right. If now in this number, the inches double value. Okay, yeah. So when we get here, let's take let sign equals, I don't know, is there a signum SG sign bit? No. All right, got a double. There's got to be something that asks if it's negative. I guess I can ask if it's less than 0. Sign. X conversion sign is minus is not the same as x less than 0. X dot sign equals minus of x is minus 0. Yeah, we don't like those. I guess I got to ask if it's less than 0, right? That's maybe the best way. Remaining is less than 0. Okay, and then remaining okay, let's get a test in here for, I don't know if we have an imperial test yet. Imperial formatter test, yes. Okay. This function is test negative units. Okay, the example is -1. We expect -1 inch. Well, I guess that means we should do 0. Expect 0 inches. Our input is a number going in. Okay. -12, expect -1 foot. -13, we expect -1 foot, -1 inch. -36 is -1 yard. minus 37 is minus 1 yard, 1 inch. And I guess we'll check 48 minus 1 yard, minus 1 foot, and 49. Well, make it 50. Minus 2 inches. Okay, that should fail. Whoops. It's really gonna fail now. Oh yeah, I gotta do something. I should be putting that in up there too. Just gives you a better message. It highlights the actual line, not the assert clause. I'm not keeping up with my to-dos here. So the big thing we did was reorganize reorganize keypad to return an entry, and calculator to use it and store it in InputBuffer. Okay, tests, we hope. Okay, 0 inches passes. These, yeah, it's got its own interesting, quirky way. Minus 1 yard, plus 2 feet, plus 11 inches is sort of minus 1 inch. All right, formatter. Okay, so now we know if the overall thing should be 0. Okay, we calculate these values. We're appending partials is value plus unit. Then we map in, and then basically, if the sign is negative, we're going to do that. Okay. Do we filter these? Yeah. So if their major value is not 0, we do that. Okay. So this is, well, let sign equals remaining less than 0 goes to minus, otherwise empty. Okay. And now we can put the sign in here. And I think my hope is that makes everybody pass. No, he's got a remaining, well, we need to work only with the positive form now. All right. But I think that should pass. Okay. Let's do it. So 0 minus 5 should equal minus 5. Yes. Okay. 1 yard minus 27 inches equals 9 inches. That's right. Yeah. Okay. I think that's doing its job. Okay, so display negative numbers. That should be -1 foot, -5 inches. Okay, that's what we're deciding. Okay. Now we'll never mix it. It'll either be 0 or all positives or all negatives. If you did as an input, that's still legit. Oh, you can't as an input. We won't let you put the minus there. Okay. So, oh, actually, this one will blow up. All right. That's okay. Excuse me. All right. So a question in my mind, well, I don't know if we did this plus or minus key. I almost think that could be our last. And I wonder if that up arrow would be a good sign for that. So I think we have one. And leftward, upward arrow. Oh, there's a little finger. Index. I guess I'm jumping ahead to this one. We got 5 minutes left. Is there anything easy? Let's look at this operator entry thing. I mean, what is operator giving us at this point? We call make, and he knows the precedence, and he knows how to evaluate it. Okay. I think we can, let's see who grabs the precedence. I mean, that should be an expression, right? We just saw it, I think. Yeah. Okay, operator top precedence. Operators is a stack of operators. I'm thinking it could be, we could push, I'm thinking it should be a stack of entries. And then when you get the one off, you're looking at the precedence of an entry. All right, let's give entry that information. Okay, so I guess this is still an operator thing. Well, why are we calling this? Yeah, we're not? That seems odd. Okay, odd but true. All right, let's do public func precedence. Precedence value. Returns an int. Okay, so given an entry, if it's add or subtract, operator. Okay, they are 3. Entry. Return 3, and if it's multiply or divide, return 5. And then the way we are now, we say anything else, return 1. Okay. So that value, where's operator? Okay, I want to find expression is using that operator.top.precedence. Operators, well, okay. All right, so here we push, we make an operator out of the description. I guess we can't do anything until we can switch this over to InputBuffer. Okay. But he's in my sights. All right, let's leave a to-do there. Decide whether, I think what I'm deciding is merge operator into entry. Okay, that'll give us a place to stop. Maybe that's worth going. I think it'll simplify these two things. Okay. We'll stop there. All right. So tomorrow we'll pick up with that merging operator into entry, see if we can get entry being used for our stack. And at that point, I think we'll tackle the negative number thing. We'll have to make sure our grammar, like right now we enforce operators just take over each other. But I think if the operator is negative, then it's probably okay. I have to think about that. If the existing operator, if there's an existing operator and you try and put a negative in, I think that should be a negate operator. And we'll go from that basis. So tomorrow, 2 to 4:30 p.m. Eastern Time and 6 to 8:30 p.m. UTC. Thanks for joining today and hope to catch you in the future. Take care. Bye-bye.